Hello everyone, this is Shweta Patil from Department of E&TC, AISSMS, Institute of Information Technology, Pune. Today we are going to discuss the topic of page replacements basics from operating system. By the end of this video, we shall understand what page replacement is about. Let us say we have two processes. One is process P1 and another process we will name it as P2, and we will assume that each of this process is of size 3 units. Hence we will divide this process into 3 parts, and we will have one main memory here. This main memory will have a size of 2 units. Hence, we will divide this memory into 2 parts. Now, we cannot place these processes in the main memory because they are larger in size. These processes are larger in size. So, we will divide memory because these processes are larger in size. And what we will do is we will divide these processes and the main memory into identical blocks. We will divide P1 in 3 parts and P2 in 3 parts and memory in 2 parts. So each part of the processes are called as the pages and the part of the memory are called as the frames. So each frame can hold one page at a time. We will name these pages as page 1, page 2, page 3. These 3 are the pages of process 1. Next, page 4, page 5 and page 6. 4, 5, 6 are the pages of process 2. Now we will assume that we need to place these pages in the memory. In the frame sequence, we will take one random sequence, that is 1, 2, 2, 3, 4, 5, 6, 5 and 6. That is, we need page number 1 in the memory, then 2, then again 2, 3, 4, 5, 6, 5 and 6. So this is the sequence of the pages which we require to store in the memory. Now I will draw the frames of the memory here. We will consider this as a memory. This memory is divided into 2 parts. So that is what is called as the frame. So the size of the memory here, it is 2 units. Let me draw it quickly. So initially this memory is empty here. Then what we need here, we need the page 1 in the memory. So we will occupy the first frame of the memory with page 1. Next we want the page number 2 in the memory. We have page number 1 in frame 1 and the frame 2 is empty. Hence, frame 2 will be occupied with page number 2. After that, we require the page 2 in the memory. As the earlier page or as the earlier frame has this page 2, this sequence will remain as it is. Here also the frames will be occupied by page 1 and 2. After that, we require page 3 in the memory. We will replace the page number 1 with page 3 and page 2 will remain as it is. Next page which is required in memory is page 4. So for page 4, we will replace this 2 page number with 4 and this page number 3 will remain as it is. Next, we require page 5 in the main memory. Hence, we will replace page number 3 with page number 5 and page number 4 will remain as it is. Next page number is the 6 which is required to stored in the main memory. We will replace page number 5 with page number 6 and 4 will remain as it is. Next sequence is page number 5. We will replace page number 4 with page number 5. 6 will remain as it is. Next again there is 6. So already 6 is present in the memory. So these page numbers will remain as it is or as they were. Now these instances where we did not have to replace the page in the memory are called as the hit. So you can see here at this instant we have not changed the page number in the memories. So this is called as an hit. There are also instances where we have removed one page and replaced it with another page. That is called as the fault. So here you can see that we have added new page. So this is a fault. Here also new page is added. This also is a fault. Here we have replaced 1 by 3. This is a fault. Here 2 is been replaced by 4. Hence this is also a fault. Here 3 is been replaced by 5. We will write the fault here at this instance. Here 5 is replaced by 6. That means this is a fault. Here 4 is replaced by 5. This is also a fault. And at the end you can see that the instances are same or the pages are not replaced. Hence this instance is called as an hit. We have certain algorithms such as the FIFO, that is FIFO, the LRU and some more algorithms which are designed to increase the number of hits. This is how we are going to be able to place the entire sequence in the memory, which could be processed by the processor at the right time. So that was a short understanding about what page replacement is about. Thank you.